So now let us introduce some important discrete random variable. And sorry, we have the discrete random distributions. We have Poisson, geometry, and the others. All right, so Poisson, geometry. Poisson, in fact, this is the figure taken from Wikipedia. And you can look up Wikipedia about Poisson. And likewise, you can use Wikipedia to look up geometry. So this is a definition for Poisson. I think no specific reason. It just follows the current form. And the form here actually it allows us to have the function definition, Poisson random variable. It should be PMF. So PMF for Poisson, this one. And actually, you can follow the previous definition, how to have an expected value and how to have a variance. So you can follow the previous formula. And previous formula after performing the integral, I think you can find, oh yes, Poisson, we have parameter lambda and the variance parameter lambda again. So about this, I think you can follow definition. And so that you can have the results. Alright, so this is the first important discrete random distributions, Poisson. And next one, geometry. Geometry, in fact, we have a different way to define geometry, but currently we follow this one to define geometry. Oh, geometry K says we have a probability P. In fact, it's the successful probability. Oh, successful probability K means all the 1, 2 to K minus 1. They are not successful, but finally K successful. If so, we have an unsuccessful probability 1 minus K for the first one, to 1 minus P to K minus 1. Finally is P. So that's why we have this probability. Therefore, geometry, yes, we have a reason to explain why geometry follow this form. Alright, so K means here number of fails plus 1 of success, so that we have K. Alright, so current definition, we have a K equal to both failures plus success. So we have this K. And actually, you can have a different way to define geometry, including number of failures rather than the successful trial. And so we have a bit different form, but their form still tractable and still follow the definition of geometry PMF. But I skip that one. Only focus on the current one defined by the textbook, and so that you can have actually the clear definition for all geometry. I avoid another one to actually mislead you to a different definition. Alright, so this one is a geometry. For this one, maybe allow you to have a few seconds to check. So 30 seconds to check Poisson and geometry. Okay, so these are Poisson and geometry. Normally, if we have the physical discussion, maybe I will chat with you to know, oh, okay, any question from you. But currently, we have the online course, so I assume you have time to chat and maybe no question, so that I go to the next page to have the further discussion. And this one is another one called binomial. Binomial, actually, we have a story. Out of n dice, and exactly k dice have the same value. All right, and this type of probability, this type calls a specific probability, and this probability form the binomial distribution. So how to have the probability? Oh, we have 1 minus p to reach the others, and p raised power to k. Yes, we have exactly same value. So same and not the same, or the others. And so that we have two different values to account for one possible event. One possible event, it says we have k same and n minus k not the same. And same not the same. Here, how many? Actually, it should be this. We have a combination n choose from k. So n choose from k, so that we have the current probability. This one. All right, so this story pushes us to have the probability density function. Oh, sorry, probability mass function for binomial. And so that we have the reason to explain. All right. And the reason to explain how to have the combination, this one, I think for the story here, you should look up. And this I don't know, for binomial distribution, we have a story behind the function. And this kind of function, it is called binomial for the probability mass function. Likewise, you can look up Wikipedia to have the share for the different probability mass function. Okay, this one. Actually, I should pause, but I think you can check it later. So let me go to the next one.